Sometimes you'll get questions where you need to find pronumerals or unknowns in a function, and you might have to use some clues to figure them out. So here's a good example. If f of x equals x cubed plus ax squared plus bx has a stationary point, that means a flat spot, at 2, 2, find a and b. Now, the first thing I'm thinking is I've got two unknowns, a and b. So if I make one equation, that's not going to be enough to find two unknowns. I'm going to need to make two equations and then solve them simultaneously. So the other thing I'll then think is underline the clues that I've been given, because I'm going to need two different pieces of information so that I can write two equations. Now the simplest thing that I can see here, the point 2, 2, this means that when x is 2, y is 2. So I'm going to use that to make my first equation. But then for the second one, I can think, well, hold on, when x is 2, I know something about the gradient. F dash x must be 0 because there must be a stationary point there. So let's write our two equations one at a time and then solve them simultaneously. When x is 2, y is 2. F of x is just y really, isn't it? So I can sub in 2 for f of x and also sub in 2 for x. Now be careful with your substituting here. I always write this line first. I've literally just subbed in a 2 for the x, and I've got b times 2, so that's 2b. And I don't do too many things at once. I can write that line very quickly, and then next I can tidy it up. Here we've got 4a and 2b, and now make the equation as simple as you can. I've got 4a plus 2b. If I subtract 8 from both sides, I'll have negative 6 over here. So I'm going to write my equation nice and simply, so that's easy to work with. I'll call that equation 1. Now for the second equation, I've already seen that when x is 2, f dash x is equal to 0 because the gradient is 0 there. So if I find f dash x first, that's the first step, I need to differentiate f of x. So go ahead and differentiate, even with the a's and b's in there, we get 3x squared. The second term we bring the 2 down and we get 2ax plus b. Now, what I know is that when I sub in x equals 2, the gradient should be 0. So that's the spot where you need to stop and do a bit of thinking. I need to let the gradient be 0, so let this be 0, and on this side I need to let x be 2. So again, careful with your substitution so you don't make a mistake. I've got 2 times a times 2, so that's 4a plus b. So here, 2 2's are 4 times 3 is 12. So if I've got 12 on this side, if I subtract 12 from both sides, I'll have minus 12 over here. So I can say that 4a plus b is equal to minus 12. And that's now my second equation. And now this looks like a nice simple problem for simultaneous equations. You can solve these with substitution or elimination, whatever you prefer. I can see straight away that I've got 4a here and 4a there as well. So elimination looks really easy for this one. I can do equation 1 minus equation 2, and that's my working there to show what it is that I'm doing. I've labelled my equations, so anyone following through this would be able to see what it was I was thinking. 4a minus 4a is nothing. 2b minus b is b. That's worked out easily. My answer is just going to drop out. And minus 6 minus 12, that's minus 6 plus 12, and that will give me just 6. Now that I know that b equals 6, I can sub that into either of these two equations to find a. This one looks the easier one to work with because the b is by itself. So I can say 4a plus 6 is equal to minus 12. And then subtracting 6 from both sides, 4a is equal to minus 18. And I've run out of room down there, but I can squeeze it in, probably a equals minus 4.5. And then to finish it off, I would finish my question by saying a equals minus 4.5 and b equals 6. Put a nice box or something around it so it's really clear what your final answer is.